Good afternoon, everyone. Myself Sana Sheikh, and today I'm going to take a live session of week 5 of course, which is entitled as Symmetry Stereochemistry in Applications, and the course instructor is Professor Anshuman Roy Chaudhary from ISR Mohali. So we have already done 4 weeks classes live session, and we have discussed various questions. So in today's class, we are going to discuss the symmetry, asymmetry, and dissymmetry of the molecule. So let's start the session. Here the question number 1 is there, and the question is indicate whether the following molecules are symmetric, disymmetric, and asymmetric. So first of all, you should understand what is symmetry and what is dissymmetry and what is asymmetry. So you should know the difference between the symmetry, asymmetry, and dissymmetric of the molecule. What do you mean by symmetry? When we have something, suppose some person is standing, or take anything in nature, you will see that there is a symmetry. In most of the cases there is a symmetry, means if I will pass the plane from here, the left side resembles the right side. So this is called a symmetry. Symmetry is there. This is a example of plane of symmetry, but there are different types of symmetry element. I have already discussed with you, like center of inversion, center of rotation, plane of symmetry, and many other symmetry elements are also there. Okay, so that type of molecules are when the plane of symmetry is present, that time it will be called as a symmetric molecule. Symmetric molecule. You can see the symmetry in universe in many cases, like suppose we have leaf. So here also symmetry is there, right? Symmetry is there. You will take anything, most probably they will have a symmetry. So that is called a symmetry. Now, what do you mean by the dissymmetry? So dissymmetry refers to a specific type of asymmetry. Before dissymmetry, we should understand asymmetry, then it will be easier for you to understand the dissymmetry. What is asymmetry? As the name suggests, asymmetric means the lack of symmetry. Lack of symmetry means symmetry is not present in those cases. So the complete lack of symmetry where there is no part of object can be mirrored or match exactly, that is called a asymmetric molecule. Suppose in molecule only we can see this asymmetry. I don't remember any example here. Um, Yeah, if to have you heard about the amoeba or parasites, different parasites? So they don't have specific shape, so you can't pass the symmetry element. So like that, there is a lack of symmetry. They don't have specific shape. In some cases, you will observe asymmetric also. If you remember any asymmetric thing example, then you can discuss with me. In any animal, if you will see that, suppose we have our hand, right? Our two hands are in enantiomer to each other. Suppose this is our foot fingers. Okay. Suppose it is there. So here you can see that if I will pass the plane, they are not mirror images of each other. Both the sides are different. So this is asymmetry. So like that, if the molecule or the object completely shows the lack of symmetry, there is no part of an object which can be mirrored or matched exactly, are called as a asymmetry. Okay. So in short, you can say that the absence of a mirror plane of symmetry, absence of plane of symmetry. If plane of symmetry is not present, that time molecule will become asymmetry. Okay. Now let's talk about the dissymmetry. Then the dissymmetry is a type of asymmetry where the molecule lacks of plane of symmetry but still has some other symmetry element. Like a type of symmetry where an object have asymmetry. Suppose in the disymmetric molecule, say Sn is present. Sn is a improper axis of symmetry. That means ref reflection followed by rotation. So first, in center of inversion will be there. S2 is equal to center of inversion, and Sn is axis of symmetry into plane of symmetry. So then rotation and reflection, which is called as a improper axis of symmetry Sn. So in these symmetric molecules, there are some there is absence of plane of symmetry, but some other symmetry elements are present. So these are known as a disymmetric molecule. It's somewhat similar to asymmetric, but not exactly. Okay. Then now let's solve this question. Indicate whether the following molecule are symmetric, disymmetric or asymmetric. So here we will see this molecule. Can you see here plane of symmetry? See, if I will pass plane from here, so this chloride should come here, right? But this is not the case. Here we have hydrogen. So this plane is not the valid plane. Okay, this plane is not giving the mirror image of the first half. Then talking about the other plane, if I will pass the plane from here, again you can see this chlorine is here and this Cl is here. So here you can see that plane of symmetry is present on this axis. You can see that, right? How the plane of symmetry? If I will dissect molecule from here, you can see that here one Cl is there, one Cl is here, right? Downside we have hydrogen, here also downside hydrogen. Here upside hydrogen, downside fluoride, right? Plane of symmetry is present. So we can say sigma plane is present. Now talking about the axis of symmetry, is there any axis of symmetry present? Yeah. If I will rotate the molecule from here, C2, this chloride will go down, right? Rotation like this. Right? 120. So here center axis of symmetry is also present. So C2 axis into plane perpendicular to C2 axis is also present, right? Horizontal plane. So as I told you, In improper axis of rotation Sn, we have rotation followed by reflection. So rotation on particular axis followed by reflection on perpendicular to that axis. So here you can see that rotation plus reflection is observed. So this is nothing but S2 because C2 axis is there. That's why S2. Okay. So S2 is equal to center of inversion. If you will see in deep, why center of inversion I will explain here. If you will see molecule here, okay, so here if I will consider this as a center, here center, okay, I, and if I will go this direction, H is there, right? If I will go in other direction, again hydrogen is there. If I will go in upward direction, chloride is there, and in downward direction again fluoride is there, right? So this is called a center of symmetry. This is called center of symmetry, which is denoted by I, which is equal to S2 and C2 sigma plane. Okay. So in this case, you can see that plane of symmetry is also present, center of inversion is present, and improper axis of symmetry is also there, and axis of rotation. So that's why the molecule is become symmetric. Plane of symmetry is there, right? So that's why the molecule will become symmetric. The symmetric molecule is always a achiral. Achiral means it will not rotate the plane polarized light. Achiral molecule. Okay. If the molecule will show some optical rotation, that time the molecule is called a chiral. But here it is symmetry is there. That's why the molecule will become achiral. Okay. So next question. The answer for this question is the molecule is symmetric and achiral. Next one is indicate whether the following molecules are symmetric, disymmetric or asymmetric. Again the same question, and we have here molecule. Okay. So in this case, I will write in open form. It will become more easy for you. CH2 okay. So if I will pass plane here, these two sides are same, right? So there is a plane of symmetry. Plane of symmetry is present here. So whenever the plane of symmetry is present, the molecule is become achiral. Again symmetric. Axis of rotation is also there. If I will rotate it by C2, it will give a same molecule, right? But center of inversion is not there because improper axis of rotation is not present. Why? Because the plane and the C2 axis both are parallel to each other, not perpendicular. So we can say that the molecule is symmetric. Symmetric and achiral. Got it? The molecule is symmetric and achiral. Next, Here you can see that the question is again the same. We have to find out the symmetric, resymmetric or asymmetric of the molecule. Which one is the, we have to categorize the molecule, right? So in this question, we have here the molecule. We have here one CO2H and one CH3. So I will write in this form, this way, CO2H, right? CH3, OH and H. Okay. Now, if we see this molecule, how many chiral centers are there? And what is chiral center? First of all, what is chiral center? So a chiral center is the center where all the substituent or valencies of the atom are different. So here you can see all the four substituents are different on carbon. So that is called a chiral center or a chiral carbon, because one is OH, one is H, and one is acid group and one is methyl group. So that's why this carbon has four different groups. So this carbon is called as a chiral carbon. Chiral carbon. Okay. So here we have one chiral center, correct? And if I will pass the plane, suppose I am passing the plane from here. Okay. So these two halves are not the same, correct? These two are not mirror images of each other. If I will pass the plane this way, again the same case, this is not the mirror image of each other. So that's why there is no plane of symmetry is present in this case. You can try the other ways also, but you will observe that because of the chiral center, one chiral center, there is no symmetries possible in this case. So that's why the molecule is become asymmetric. Asymmetric and chiral. Chiral and asymmetric. So first of all, you have to search about the plane of symmetry, improper axis of symmetry, and rotation of axis. But if all the elements are absent, so the molecule will become asymmetric because there is no symmetry element. No symmetry element. There is no improper axis of rotation, no plane of symmetry, no axis of rotation, no center of inversion. There is no symmetry element is present in this molecule. Okay. I hope you got it. Next, indicate whether the following molecule are symmetric, asymmetric, and asymmetric. Again, so this is the cyclopropane, 2,3-chlorocyclopropane. In this case, so here we have cyclopropane sorry, 1,2-chlorocyclopropane. So in this case, if you will see here, we have plane of symmetry. From where, if I will cut the molecule from here, you can see the plane of symmetry is present, right? Here you have Cl, Cl, hydrogen, hydrogen, right? These are mirror image of each other. So there is a sigma plane is present here, correct? Sigma plane is present. So when the plane of symmetry is present, that time the molecule will directly become a symmetry. I told you earlier, so this molecule is symmetry. And if the molecule is symmetry, then it will become achiral. Okay. So here, any other symmetry element is there? If I will rotate the molecule and then reflect, will it give the same molecule? So if on this axis I will rotate the molecule and then plane will be passed on this way. So it will not give that molecule. So SN axis is not present here again. SN is not there. Okay, next question. Now in this case, in this molecule, first of all we will draw the Fisher projection. I told you in earlier class, that in Fisher projection, how to draw Fisher projection, right? So here I am drawing it directly. Just try to draw yourself. If you are not getting it, go and watch week 4 class, then you will get this. Okay, if I will draw here Fisher projection, both the end have CH, correct? Now here you can see that we have two chiral centers, correct? These two are chiral centers. So why chiral center? Because all the four substituents are different on these carbons. But again, after having two chiral centers, still the molecule can be a chiral also. So we will see in this case here, if I am imagining the molecule from this side, like this way. So this CH3 back side, OH is on my left side. Okay. H. So these two are opposite side because zigzag form. So this is the molecule we will get in Fisher projection, right? So this is the Fisher projection of the molecule when I will pass the plane from here Is the molecule is same? No, right? So I will draw here. This is nothing but this form, right? OH, OH, correct? So here, if I will pass the plane of symmetry here, these two are not the same halves because here the OH group is coming towards myself, but here OH is going backside. So this is not the correct half of this molecule. So that's why this plane is incorrect. Other way is possible. Anyone? If I will pass the plane this way, so again this is not possible because here OH group, both the OH group are pointing in opposite direction, right? So that's why there is no plane of symmetry is present. While I will see that this molecule have the another enantiomer. If I will rotate on this axis, if I will rotate the molecule on this axis, C2 symmetry, it will be show OH, H, H, Cis, right? These two molecules are same or different? They are mirror image of each other, but the molecule is not the same, right? The molecule is no longer same because if you will see the RS configuration, 1, 2, 3, it's going like this way, and because of H it will become R. So here if I will give the numbering 1, 2, 3, this is going this way, but because of H it will become S. So these are two different stereochemistry. That's why these are enantiomers. Enantiomers, why? Because these are mirror image of each other, but there is no plane of symmetry present in this molecule. So because of that, the molecule will become achiral. Sorry, chiral. Asymmetric and chiral. Okay. Next example. Yeah. In this molecule, again we have two chiral centers. In previous case also we had two chiral centers. Here also we have two chiral centers. So we will write the molecule in the Fischer form here first. CH3, CH3, and three carbons are in between. So if I am imagining the molecule from top side, this OH is on my left side. Then again this OH is on my left side. H, 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 H. Okay. Now, can you see here plane of symmetry? If I will pass the plane from here, okay, these two halves are same, right? So that's why we can see here, because both the ways are pointing outside, outward, there is a plane of symmetry because these two are exactly same part, same halves of the molecule, right? So the sigma plane is present in this molecule. Despite having a two chiral center, the molecule will become achiral because of plane of symmetry. Okay, the plane of symmetry is present here. So because of this symmetry, this molecule will become, there is no axis of rotation. Yeah, no, sorry. Axis of rotation can be possible from here, C2 axis. Okay. So because of this one, this molecule is become achiral because plane of symmetry is present. So the molecule is comes under symmetric category. It is a symmetric molecule. Got it? So remember here, if the chiral center doesn't define the molecule's chirality, molecule could have be can be achiral if chiral centers are present. And molecule can be chiral also when there is no chiral center. We will discuss a few more examples. Okay. So in this case, draw all the possible isomer of the following compounds and determine which molecule will be optically active. So here we have given two questions. The first one is, if I will draw in zigzag form, first I will convert the molecule in zigzag form. Okay. How many carbons are there? 1, 2, 3, 4 and 5. Okay. 5 carbons are there. 1, 2, 5. Okay. These are 5 carbons. So at one end we have CO2H and at another end we have CO2H. Okay, got it? Now I have to write the OH. How many possibilities are there? So on all the 2, 3, 4 carbon we have one hydroxy. So in one case, first case, I will keep all the hydroxy group on same side. On wedge position, sorry, not same side. So you can see here we have 3 chiral centers in this case. How many chiral centers? 3. Correct? So in stereochemistry, you should remember one rule. The formula is there. One formula is that 2 raised to n, where n is the number of chiral center. Chiral center. So here we have 3 chiral centers. So 2 raised to 3 will become 8. So there is 8 possible isomer. 8 isomer are possible in this case. Okay. So we have to draw all the possible isomer here. So I will draw it in Fisher form first. Sorry, CO2H. Okay. So in one case, all the OH are on same side. So by keeping 2 OH same, I will write the other possible isomer. So here OH will remain as it is. Here I am going to change it. Okay. This is one possible isomer. Okay. Got it? What is the other possibility? First and third carbon OH is on same side. Only the middle one is going to change. So these are 4 different isomer possible. If I will take the enantiomer of these 4 isomer, we will get total 8 different isomer. Enantiomer is possible. All will have different mirror images. So that's why these 4 will show the other 4 isomer. I can draw here if you want. Like this way. CO2H, OH, H, H. what's the difference here? Anybody? Here you can see that we have both the acid group on both the end, right? If I will have molecule like this, I can pass the plane of symmetry here. Is it possible? So in these two isomers, there is a plane of symmetry possible. While in these two isomers, there is no plane of symmetry. Correct? So you have to find out the which molecule plane of symmetry is there and in which the plane of symmetry is not present. So these four isomers are meso. Meso means they will not show any optical rotation. These four isomers are achiral and the other four are chiral. Okay. So you have to differentiate. You should have differentiate between these isomers. This is the first case. Now let's talk about the second one. Second one is similar to the first one. So I hope you can do this question. I will just give the hint. So this is homework for all of you. If you are not able to solve it, you can ask me. But I will just give a hint. CO2H, OH, OH, OH and CH. So despite having all the OH atom on same side, this molecule doesn't have plane of symmetry because of the two different substituents present on the terminal carbon. Okay, these are the different ones. So that's why there is no plane of symmetry is present. So in this molecule, again, see three stereo centers are there. Two raised to the sorry. To the power 3 equal to 8 isomers, and in this case all the 8 isomers will be chiral. There should be no plane of symmetry. You should solve this question by yourself. If you are not getting the correct answer, then we can discuss in the next class. You just let me know. Next question. Determine whether the marked H atoms H, A and B are homotopic, anisotropic or diastereotopic. So here we have to find out the topicity of the hydrogen atom. How we can find out? Anyone? Okay. Some error was there with the Google Meet. Sorry for the inconvenience. in this example, we have to find out the topicity of the hydrogen atom. So, when first of all we have to find out the molecules symmetry, right? Here HA is there and HB is there. If suppose I will change the HA by some halogen atom or any other atom called X, okay? So I will write here this way, bromine X, HB and bromine, correct? Now rotate the molecule. Rotate the molecule on this axis. -180 degree. Okay. What I will get here? X, correct? Br and Br HB. So, can you imagine these two molecules? Sorry. Can you compare these two molecules? Here you can see that at the place of HA, HB came after the rotation, right? HB came after the rotation. So you can see that if I will exchange this HB with X, again I will get the same result after rotation, right? So there is a rotation of axis is there, correct? If suppose this molecule is showing some S and R configuration, correct? So because after the rotation the molecule HA takes the place of HB and HB is taking the place of HA, so that means these two H atoms are homotropic. Why is these are homotropic? Because the changing any of the atom are giving the same result, right? So that's why they are called as a homotropic hydrogen atom. And in this molecule there is a plane of symmetry is also there. If I will pass the center of inversion is there here, so you can see that center of inversion is there, right? So the molecule is a chiral and these two hydrogens are homotopic to each other, okay? Homotopic to each other. Next question. Here again we have to find out the topicity of the hydrogen atom. So in this case we have one chiral center. This chiral center, correct? Suppose I will again change the one atom by X. So in this case I am going to change the XB as a X. CO2H. Here we have HA and on back side we have X, correct? And in another case just change the HA atom, CO2H, HB will remain as it is and here is X, correct? If I will rotate this molecule on this axis, okay? I will rotate the molecule on this axis by 180 degree. What I will get? Here I will get CO2H. This group will come on this side, correct? Here CH3. This X will go back side of the plane and XB will come on the front side of the plane. Correct? All of you are agree with this? Now, just compare these two structures. Are they mirror image of each other? They are, because you can see this CO2H group is here, this is here, right? If I will pass the mirror between these two atoms, these are mirror images of each other. So always remember, whenever the molecule are mirror images of each other, they are nothing but the enantiomers. So that's why these two proton will become the enantiomers, enantiotropic. These are enantiotropic. Okay, enantiotropic, and these two isomers are enantiomers. If I will change the HA and H2, I will get, if I will change the HA, I will get the different enantiomer, and if I will change the HB, I will get the different enantiomer. So there is a two different enantiomers. Okay, so that's why HA and HB are enantiomers, enantiotropic protons. Let's talk about the other one. Next example is this one. In this case, you can see that in this molecule, if I will change one HA by Cl, okay, so here I am going to change it by Cl, H, UH, UH and CH3. Got it? And the other case is where I will change this HB with Cl, HUH, CH3, CH3. Here again we have two halogens, right? So if I will rotate the molecule by 180 degree on this center. Okay, what I will get? Correct? This one. But can you imagine the molecule I will rotate on plane of the paper? Plane of paper means just look at this molecule from opposite side. Or we can say that just rotate it like this way, 180 degree on plane of paper. So we will see, you will get this molecule, right? Right? See this molecule from the opposite side, from this side, and this molecule is from this side. Both are same, right? And these two molecules are mirror images of each other. If you will see here, these are mirror images of each other. Correct? So again the mirror images resembles the enantiomers, correct? So these two molecules are enantiomers of each other, and because these are enantiomers, so the proton will become enantiotropic. Okay. So these protons are enantiotropic to each other. Next one. Let's try to solve this question again by yourself. The same thing we have to apply. Every time we have to do the same thing. What I am doing here, just replace the one H atom with any other atom. Okay. Got it? Now, the other possibility is there. Okay, got it? So now what we have to do, we have to do the possible rotation. So if I will rotate the molecule, on this axis by 60. By 90 degrees, sorry. X will come here, H, Br, H, correct? Cl and H. Got it? Now, just flip the molecule. Flip the molecule. If I will flip the molecule, you can see that with this X, Cl is on the same plane, right? And bromide is on opposite plane. But with this X, Cl is on opposite plane and bromide is on same plane, same side, right? Same side. So that's why we can see that here both the X are giving a different electronic environment, or we can say different atoms nearby the H atom, right? So different surrounding, different environment of X is showing these two HA and HB are different, right? So that's why these two H and HB are called as a distereotopic. Distereotopic. Because both the H are giving a different environment. We tried to do the rotation and find out the surrounding, but here you can see this X is on the same side of Cl, but while this X is opposite to Cl and same side on Br. So because of the different surrounding and environment, these two H are distereotopic, and the two different molecules are distereomers. Distereomers. Okay. Next question. Here again we have to find out the capacity. I will do the same thing. CH3 CO2H X OH H and H. While the other way is we will change HB as X OH H H CH3 CO2H, right? if I will pass the mirror here plane, what I will get? CS3 so correct. Here you can see that the X and OH are in opposite direction, right? But here is on same side. So these two are nothing but different thing here. If I will write this way, OH, so this X is on opposite side in this case, correct? And in other case, this is on same side. These two are not mirror image of each other. These two are different. You can imagine this one. These two are not mirror images of each other, and the XA and XB will give a different isomer. So that's why these two protons are distereotopic. And there is no symmetry element is also present. That's why the molecule is chiral and distereomers. Stereomers. And protons are distereotopic. Okay, got it? The next question is, yeah, similar type of question again. So I will write the same way first. Sorry. Okay. If I will draw the molecule here, this will become OH, X, H and Br. Correct? So here OH is on fixed position, it is on wedge, correct? And here backside is X, and here backside is Br. So you will see that these two molecules are totally different, right? Totally different. These are diastereomers again. So the protons will become the diastereotopic because the different H substituent will show the different isomers. Okay, the molecule is diastereomers and the proton are diastereotopic. So I hope you understood the difference between the homotopic, anisotropic and diastereotopic, because we have solved the question based on all the three options. Examples like homotopic question we have solved here, anisotropic question also, diastereotopic also. So whenever the symmetry element is present, in case of anisotropic and distereotopic, the molecule will become chiral. And when the homotopic protons are there, then the molecule will depend on the other substituent of the molecule. It can be chiral or achiral. Okay. So I hope all of you understood here the difference between the symmetry, dissymmetry, and asymmetry of the molecule. So till here we have discussed the question based on topicity and the chirality of the molecule. In next lecture we will discuss the different things. Okay, if you have anything, any question regarding these things, you can ask me on next class. In next class, or you can write on YouTube comment section your question. I will feel happy to answer your question. Thank you so much for your attention. Thank you.